right? Can I erase? And then you can put the first topic. We're starting with uniform acceleration in a straight line. So I will leave that on the board. That's our first topic. Just start with it. Uniform acceleration in a straight line. Or it's called linear motion.
And it is like linear motion as the main topic.
Yeah. But you will miss out the important that is important. Uniform acceleration. The whole underlying thing about this topic is that we are considering motion. What kind of motion? Uniform acceleration. What do you mean by uniform? Constant, not non-changing, same acceleration, one value of acceleration. If it is 3 meters per second squared, 3 meters per second squared throughout, without changing. That's uniform acceleration. Yeah, it's Jim.
Something not something.
Yeah. So I work better when I'm drunk. Okay. Now, so I'm going to start this assuming that you have some basic understanding about motion. Now, when you hear the word motion, this is all about motion. Unfortunately, this topic doesn't have the word motion. This is about, we are learning about moving objects, not any moving objects, moving objects with a constant acceleration, okay, in a straight line. Two conditions. We are learning in this topic about objects that are moving in a straight line with a constant acceleration. Please put those two important key things into your head in the beginning itself. Okay, this is about motion, not just any kind of motion. This is motion happening in a straight line. Any straight line, basically, you can only move back, forwards and backwards. You can't go like that or in a circle, or, right? Straight line motion, and with a constant acceleration. Okay, right. So, but the word motion. Yeah, sure. Okay. So basically, this is about movement, right? Moving objects. Now, so I will start off with some basic definitions that I think that you already know, but I will give these definitions to you. But I will not spend a lot of time talking about this, but we're going to start with these. That's where I'm starting. So I assume that you are there already. I would assume that you are familiar with the basic terms related to motion. What are the basic terms related to motion when you are thinking of something moving? What are the physical quantities that you can talk about that motion? You can talk about the distance traveled. You can talk about the speed with which it is traveling. You can talk about something called the displacement. You can talk about the velocity. What's the difference between speed and velocity, by the way? And you can talk about, is it changing speed? That means, is it accelerating? Right? Or is the speed constant? So these basic terms related to motion: speed, velocity, distance, displacement, and acceleration. These 5 terms, you have to know what they mean. But so let's quickly go through each of them. So the first subtopic, basic definitions related to motion. We'll start from there because these are words that will come up all the time in this while we are in this topic. Speed, velocity, acceleration, distance, displacement. These are the things that we will talk about. Okay? So you have to know what they are. So first topic, basic definitions related to motion. Basic definitions related to motion. Now, so here related to any motion first, okay? Related to motion. So I'm not restricting to linear motion, I'm just talking about just motion, any movement. Basic definitions related to motion. Number one. Distance. I'll give you a small diagram. If something is moving from point A to point B in that path, so this is just a random motion, okay? When you say distance traveled during this motion, what you mean is the actual distance traveled, this total distance traveled. How far did you actually move along your path? The word distance is what you usually know as, so you might be thinking, are we learning the definition for distance? We know what distance is. Distance, right? Tell me why we are learning the definition of distance. This is to differentiate between the word distance and what comes next, displacement. Okay? To show you the difference between displacement and distance, you have to know what distance is. Because it's a normal word we use all the time. It's the actual travel, length of travel. Yeah, how far you traveled actually. Okay? So you would have to count your path. This is number of steps or the number of meters you moved. Okay? So distance definition is the total distance traveled is the total distance. The key word is traveled. The total distance you actually traveled from start to end. From start to end. From start to end. So it would be, you would have to, right, go like that and think about the whole distance. This is what distance is. Distance traveled is what distance. When you say distance, you are thinking of distance traveled. Second word, displacement. One more thing. As a quantity, you measure distance. The standard unit of measurement for distance is meters. And this is known as what kind of a quantity in physics? You know, these physical quantities, these measurable quantities in nature are called physical quantities. And there are basically two types of physical quantities that exist in the world. Scalar quantities and vector quantities. Distance is a scalar quantity. It doesn't have a direction connected to it, right? It's just distance travel. How far did you travel? 5 meters. That's it. It just has a value. So let's just note that also in brackets here. This is a scalar quantity. So I'm assuming that you know what a scalar is. Only has a size. I traveled 10 meters to get here. What? I traveled about 40 kilometers to get here. I think. I think so, yeah. Okay, next, quantity displacement. Displacement. Again, if I take the same motion, somebody is moving from A to B, if I take the same motion, right? What I mean by displacement of this motion is the net shift from start to end. I don't care how I went from A to B. I could have gone under that, or I could have gone like that. I mean, it doesn't matter the path I took. When you talk about displacement, all you care is about what's your net shift from your starting point. How much have you shifted? It's the direct distance from A to B. Direct distance from A to B. So you shift. You started your journey here, you ended up here, you have shifted by this amount, by that amount. That is called displacement. Okay? It's not how far you traveled, it's how far now. You know, we say, I got displaced. When you get displaced, you say, you're displaced, yeah, your displacement, right? So displacement is the net shift the net shift. It's independent of the path you took from A to B, from your starting point to your ending point. It's independent of that. We don't care about that when we think of displacement. So it's the net shift from start to end. From start to end. And it is a vector because it's measured in meters again. Because you have to say, now, so I start my journey from A, I have ended up at B, my displacement is now I have to say where you are in relation to your starting point. I am to the, what is the direction? North,
South,
east,
east,
east, southeast. Like in a southeast direction to A. I'm now 10 meters away in a southeast direction to A. Like you have to give it relative to A where you are now, your new position in relation to where you started. And you have to give the direction, right? Because when you are saying, now for example, if I say I got displaced by 2 meters, now I'm standing here, I got displaced by 2 meters. Can you tell me where I originally was? If I just say I got displaced by 2 meters, where was I before I got displaced? You can't say without another explanation. I have to say I got displaced 2 meters to the north. In another direction, I have got displaced 2 meters. Then my original position was behind me. If I give you it as a vector, you know where I started. So it's a vector, okay? It has a direction. You have to say it with the direction. Third, number 3. Can I erase? No. Number 3. Shortest distance?
Yeah. That's correct.
Yeah, that's correct too. You can say shortest distance between your start and the end point. It's the direct distance. Net shift. Shortest distance, that's another way of saying it, yes. Third quantity related to motion is speed. When something is moving, you can talk about the speed of the thing that is moving. How fast is it moving? In 1 second, how many meters is it moving, right? Speed. Speed is distance traveled per unit time, some unit of time. Distance traveled per unit time. So the unit with which speed is measured, the standard unit is meters per second. Distance, meters, displacement, meters, speed, meters per second. That's the standard unit. There are so many other units with which we use, with which we measure speed. Kilometers per hour, miles per hour. Can I know some other units for distance or displacement other than meters? Kilometers. What's the largest unit you know for distance? Terameters, okay. Something bigger than that? Hexameters, okay. Miles. Those are even bigger. With what unit do you measure distance between stars? Light years. Isn't that a unit of time? Light years?
Yes.
Light years, is it a unit of time or unit of distance?
Distance.
It's a unit of distance. How long is 1 light year?
1 million.
1 million what?
How long?
A light year is the distance traveled by light in 1 year. Wait. For you to get an idea of how long that is, it takes, wait, listen to this. For light to come from the sun to the earth, it takes about 8 minutes. That is the distance traveled by light in 8 minutes, the distance from the sun to the earth. then just imagine how far light could travel in 1 year. Do you like feel it? Okay, that's what 1 light is. So the closest star to us after the sun is about 4 light years away from us. It's about 4. That's the closest star other than the sun. 4 light years. So 1 light year, you got the idea of one. Huh? Speed of light is 3. That's mathematics. See, that's a good question. How do we know that the speed of light is 3 into 10 to the power of?
Maths.
10 to the power of? 8 meters per second. Did we do that? Did we let the light come here? Can you travel and can I measure? Who did this? How do we do it? I'm not going to go into this. That is all math. Indirectly, you're not like actually measuring by keeping a stopwatch. Let me see how far you travel in a second and then compute. Something like that. It's the same way. Now, these are interesting questions to think. How have we found the diameter? How do we know the size of the Earth? We know the diameter of the Earth. We know the circumference of the Earth. We know the distance from the sun to the Earth. Who went and measured it? Right? So all that is math. Okay? We make certain observations, we draw diagrams, and we apply trigonometry maybe, and we don't actually measure it, we compute it, we calculate it, but we just make certain we take certain measurements, like how long the Earth takes to complete 1 revolution maybe, and how do we get that? By observing the background, the movement of the sky, we can see all these are based on observations, and then you compute. So this is astronomy. We'll continue. Speed is distance traveled per unit time, and it's a scalar. It's a scalar. If I ask you the speed of something, you don't have to tell me in what direction it's moving. You just say it's 2 meters per second. That's it. All you care when you talk about speed is the size of the speed, how much it is. 10 meters per second, 3 meters per second, what the amount, not the direction. Okay? And so you can write the formula for speed. Speed is equal to distance divided by time. If you know the distance, it's not displacement, you have to know the distance. Distance traveled divided by time taken. In short, we just say distance over time. Speed is equal to distance over time. So if you know how far something travels within a certain time, you can calculate its speed. Speed is distance over time. Distance traveled over time taken. Okay. Fourth quantity, velocity. Now, what's the difference between speed and velocity?
Displacement of speed. No, displacement.
I didn't get that.
Displacement is change in distance. Change in distance or time.
So, for example, shall we do an example? Let's assume this distance. Let's assume that this distance is 35 meters. Okay, and say this person took 5 seconds to move that distance. Okay. Yeah, close call. 35 meters in 5 seconds. What's the speed of that object?
7.
35 divided by 5. You have to divide the distance traveled by how long you took to travel that distance. Okay, so here for that particular example, speed would be 35 divided by 5. That is 7 meters per second. Okay? That's what speed is. The speed from A to B. Speed from A to B is distance traveled from A to B divided by the time taken from A to B. You are calculating speed for a certain part of your motion, in this example A to B. So that's the speed for that motion. Your velocity, on the other hand, if I ask you what's the velocity of this object, who moved a distance of 35 in 5 seconds, what's the velocity if I ask? What am I asking and what would be the velocity? Say this is a car, let's draw a little, Oh, you need the displacement for that? Okay, suppose this is, if that is 35, this could be like maybe 20 or maybe 20. So let me say this is 20 meters. What's the velocity of that object? Are you paying attention?
4 meters per second.
Yeah, what velocity? I gave you the time already here. This person has taken 5 seconds to travel from A to B like this. He traveled 35 meters. His final displacement is 20 meters. When I ask you the velocity of this person, what I want you to compute is what?
How long it takes, the rate he covers that 20 meters.
Yeah, yeah.
In 98 speed, that is the time taken to travel that distance.
That is, yeah.
So, if he was to travel a displacement, then they could not sort of like that.
No.
Why not?
If he were to travel at the same speed along this path,
Yeah.
it would be a short time, yes. But that's not how we travel. We travel like that.
So,
Right?
when we calculate displacement, do we use that time or the time taken to travel from?
This time, how far he took to travel from A to B. But, so what is velocity?
Rate of change of
Rate of change of displacement. How much of displacement happened per unit time? This is what distance was traveled per unit time. Here I'm asking the amount of displacement per unit time. So you have to take the net displacement from A to B and divide by the time he took for that displacement to occur, right? So it's 20 divided by 5. He actually went 35 meters, but his velocity is, so in other words, when you give the velocity, you are computing if he went directly from A to B within that time, what would be his speed? Something like that. Right? So this is in a straight line, in one direction. Okay, so it's the displacement per unit time. This is the distance per unit time, distance traveled per unit time. Velocity is the displacement happened per unit time. Displacement per unit time. How much he got displaced, by how much he got displaced in 1 second during this motion. Displacement per unit time. Same unit, meters per second, but you have to give the direction. It's a vector. You have to say in this direction. The velocity was in this direction. It has a particular direction, not like here. Here he's changing the direction throughout the journey. Okay? Velocity, when we are talking about the velocity, you are talking about from the starting point to the end point, in what direction he has displaced and how fast per unit time, right? That means rate of change of displacement. Is this clear? Now you have to engage your thinking with what I'm saying. If you just, then you have to think about it. Then only you will understand what I'm saying. So I can't do that for you. That you have to do. Okay? So it's a vector, and then if I'm to write like a formula, velocity is equal to displacement divided by time. Okay? We don't care what path he followed. You have to take the final displacement. So velocity is equal to. You write properly. I'm squishing everything onto the board, trying to manage the space I have. So it's not very neat and clear. Displacement. You have, did you not write here? You have to write everything writing on the board. And even this example. Displacement over time taken, the time he took for that displacement. For Talibu's question earlier, he took 5 seconds for that displacement. So again, I will do, as an example, if I calculate the velocity of that person, yeah, I will write it. I'm very sorry that this looks very messy and very, this is not very untidy. Please, you write it properly. Take space and nicely write. I'm calculating the velocity for that example. The same person, I'm considering the same motion here. This person moving from A to B along this path. He traveled 35 minutes in 5 seconds. His displacement is 20 meters. So his velocity would be 20 divided by 5. So 20 divided by 5, that is 4 meters per second in this direction. You have to say it. The displacement happens in a certain direction. How much have you got displaced? And in what direction? So you have to say how can you describe that? So it's vaguely. Vector, yeah, you can. That I mean, but yeah, you have to know the locations of A and B then, like in AB direction. I will just say in AB direction. Can you even see what I'm writing?
Yes.
Can see, no? So in practical situations, you would actually say 30 degrees to the horizontal or something like that. You can describe that direction using some information. So I will just say AB direction, in the B direction. And the last physical quantity that is related to motion is things could be moving at a constant speed or things could be moving with changing speed. If you are changing your speed uniformly, say you're speeding up, you're gaining speed. And if you are gaining speed uniformly, what does that mean? Every second you gain the same amount. Every second you gain the same amount. Or maybe you're slowing down. Then you're losing speed uniformly. We are talking about uniformly. If you are changing speed, that is called uniform acceleration. The word acceleration is used if you are changing your speed or changing your, if you are changing, not speed, if you are changing your velocity. Wait. Can I can't erase. I'm going to erase the top part here. No, I will not. I will erase this also. Acceleration. Number 5 is acceleration. Like a normal description for acceleration would be, when would you say that something is accelerating? Whenever not the speed, the velocity is changing. Whenever the velocity is changing, you have to say, he's accelerating. Okay, that's a normal meaning. Let me just write that first. That's not the definition. This is just a description. Whenever yes.
If you say changing velocity over time.
Yeah, that's a formula. I'll get to it in a bit. Changing velocity over time taken is the formula for acceleration. The word acceleration, the meaning of that is if the velocity of a moving object is changing. Whenever the velocity is changing, notice the word changing. I didn't say increasing. I didn't say decreasing. It could be an increase or a decrease. If it is changing, then it is accelerating. Whenever the velocity is changing, we say the object is accelerating. Okay? So, even more simple words, if you are speeding up or slowing down, that is accelerating. Okay? Speeding up means your speed is increasing. Slowing down means your speed is decreasing. not your speed, velocity. I will tell you why we take the velocity here. So acceleration is a vector quantity. Maybe we say the object is accelerating. Then, if I say something is accelerating, how do you know whether it is actually gaining speed or losing speed? Like two things, a change could be an increase or a decrease. How do we differentiate between those two? Like if I just say something is accelerating, are you able to tell me whether it is speeding up or slowing down? The velocity can change in two ways. It can speed up or it can slow down. If I just say something is accelerating, are you able to tell me whether it is actually speeding up or slowing down? No. So we need a way of like indicating that when you say something is accelerating. You can say positive acceleration and negative acceleration. Positive acceleration means actually speeding up. Negative acceleration means you are slowing down. Or there is a special word for negative acceleration. Deceleration or retardation. That's a separate word that you can use for negative acceleration. That means you are slowing down. Okay?
Then we can use acceleration and decay.
Yeah. So if you are, this is what I said. If you are actually speeding up, okay, there are different ways in which you can say it. You can say it's positively accelerating. It's a positive acceleration. If it is slowing down, you can say it is a negative acceleration or deceleration or retardation. Right? If you want to stick to just the word acceleration, you can use a sign to say whether it is speeding up or slowing down. If you want, you can use that separate word, retardation. Or we have two words, deceleration or retardation. Yes, we do. Okay? And the definition of acceleration, this is a description, right? Definition is, so you would say that something is accelerating if the velocity is changing. If I ask you, how much is the acceleration or what is the acceleration of that object, you have to like give me a numerical value, and how do you do, what would that be? So the definition of acceleration is how much the velocity changes in a unit time. You say that something is accelerating if the velocity is changing. And how do you compute the acceleration? By computing how much of velocity, how much of change of velocity is happening per unit time. In 1 second, how much does it change? How much does it drop or how much does it rise in 1 second? So the change in velocity per unit time is the definition of acceleration. That's how you compute it. So in red, acceleration is change in velocity. Change in velocity per unit time. What's the unit of acceleration then? What's the formula?
Meters per second square.
Meters per second square. So this is a vector. You have to give the direction of motion, correct? Because it's velocity, you are just looking at the line through which it got displaced along that. And then the formula, acceleration is final velocity minus initial velocity. You have to work out how much the change is. Final velocity minus initial velocity divided by how much time it took. Time taken for the change. This is the formula of acceleration. Now, you have done all this in your O levels, haven't you?
Yes.
Yeah, okay. So the unit, if you like, need, unit is meters per second square. Do you see how you get this? Top here is velocity, meters per second, divided by another second in the bottom. That gives you meters per second square. It's ms minus 1 divided by s, that is meters per second square. Please make sure that you understand every little thing. I'm just showing you everything. If you need anything, you copy all that. You don't have to necessarily write down everything that I write on the board, but I'm just, because I'm not sure whether you all know all this or not. And from this formula, you should see how a retardation becomes a negative value. If you are slowing down, your final velocity would be a small number, minus initial would be a bigger number. You get a negative answer. If you are decelerating, when you use this formula to compute acceleration, you are going to get a negative number. Say, for example, say first you are moving at, say from A to B something is moving. Here your speed is, you will learn these symbols later, I'm just using them now. Initial velocity, the standard symbol we use is U. Say U is 25 meters per second here, and when it is passing B, it's slowing down. Final velocity at B for this section of motion, say is 5 meters per second, right? And he takes 5 seconds to travel from A to B. What is his acceleration? I'm asking what is his acceleration? It's actually decelerating, not accelerating, not positively accelerating. It's negatively slowing down. So if you calculate the acceleration, A, you would do 5 minus, final minus initial, 5 minus 25 divided by 5 gives you, this is negative 20 divided by 5, you get negative 4 meters per second square. What does that negative mean? It's decelerating, it's slowing down, right? You calculated acceleration, you got a negative acceleration. That means it's decelerating, retardating. Yeah? Right, any questions up to this? These are the basic definitions related to motion. Distance, displacement, speed, velocity, and acceleration. Out of these, distance and speed are scalars. You don't have to specify a direction when you say those. Displacement, velocity, and acceleration are vector quantities, which means if I ask you any of these three, when you give the answer, you have to give the numerical value along with the direction in which that happened. Like if I ask you the displacement of something, you have to say 5 meters in this direction. If I ask you the velocity of something, you have to say 10 meters per second in this direction. If I ask you what the acceleration of an object is, it's 10 meters per second squared in this direction. Is that clear? You have to give it with the direction, size of the quantity and the direction in which it happened. Right. Then let's write an introduction to, so this is, our topic is uniform acceleration in a straight line. So we will just write a sentence about what kind of motion we are studying here. Our object has to be traveling in a straight line and it has to just have a uniform acceleration. Please don't hesitate especially the two new, you're not new, but your face is new to me, right? Don't hesitate to ask anything, okay? If you don't understand any little thing, please stop me and ask. Otherwise, no point. No point in having this class. Okay, so what do you mean by uniform acceleration then?
Constant.
So if it is constant, it's not speeding up.
No, it's speeding up at a constant rate. The rate is set.
That means, say there is an acceleration of 5 meters per second square. Now, tell me what this means in words. Break this down into words. What does this value mean? 5 meters per second squared means positive, right? The object is every second the velocity is increasing by 5 meters per second. Is that clear? Every second the speed, not the speed, the velocity is increasing, this is positive, by 5 meters per second. Every second increases by 5. So if you actually think of the movement, if I start with 0 velocity, after 1 second my velocity would be? My velocity would be 5. After another second, 10. Next second, 15. Next second, 20. Next second, 25. This is uniform acceleration. I am gaining speed at the same rate. If this happens, 5, then 20, then 25, and then 35, and then 50. Is this positive acceleration or negative acceleration? These are velocities. 5 meters per second, next second, 20 meters per second, next second, 25 meters per second. This is velocity. These are velocity values. So it's accelerating, it's speeding up. Is it uniform?
No.
It's not uniform. First second has increased by 5. Next second has increased by another, how much?
50.
By 50. Next second increased by 5 again. Next second increased by 10. Next, so it's not uniform. Every second the gain in speed that's happening is different. It's not the same. Is this idea very clear to you? The difference between uniform acceleration and non-uniform acceleration. This is acceleration too, but it's not uniform. It's not happening at a constant rate. Is that clear? Sure? Okay?
Yes.
Right. So we'll write that. In this topic, we are only looking at objects that have a uniform acceleration. That means the same acceleration throughout the motion and also moving in a straight line. Okay? So, leave like 2 lines and start a paragraph on a new line. In this topic, what is our topic? Uniform acceleration in a straight line is our topic. Okay? Harindu. In this topic, we consider the motion of objects. We consider the motion of objects that are moving with a constant acceleration. Write constant acceleration in red. In this topic, we consider the motion of objects that are moving with a constant acceleration. These are the 2 keywords. The first one is the acceleration is constant. Constant acceleration in a straight line. In a straight line in red. In a straight line. So this narrows down the kind of objects you can look at around you. But can you think of like natural objects who demonstrate this kind of motion? First of all, it has to move in a straight line. So you can't just think of vehicles moving on the road. They will take like go like that. You can think of a vehicle moving on the highway, like a straight section of the highway at a constant. Huh? Oh, you have to leave. What's the time? Have you gone past time? No. What?
No, you just trying to say that there are curves in the highway also.
In the highway, I said a straight section of the highway. In highways, you get straight sections. Okay? Or even a very accurate straight line motion. Can you think of something? Yeah, what?
Yeah, okay.
They go and skate.
Yeah, what?
Play.
Once you have gone to the cruising level, then you'll be almost in a other you will take off would be like that and landing would be like that. Yeah, cruising level, yeah, could be a straight line. Yes. Also, so that's straight line part, and also it has to be going at a constant acceleration, right? That is very difficult to find around you. Vehicles you brake and you accelerate and you right? But think of
It's the fan.
it's moving a straight line.
No, it's constant acceleration.
It's constant speed. It's constant speed. Fans turn at constant speed, but the velocity is changing here, right? It is a constant acceleration. I'm not sure if you understand that. Anyway, don't go think of fans. It's a circular motion. It's not a straight line motion. Can you think and tell me? I can show you right now something that moves in a straight line with constant acceleration, almost perfectly. Trains. Trains, again, once they have come to their, so they gain speed fast. Okay. Light moves at a constant speed. They don't accelerate.
Straight line.
They go in a straight line. So when you satisfy one condition, the other condition is there.
Electricity.
Do you even know whether they accelerate? Do they they could be going most of the time in a straight line. They usually again cruise along a straight line, but their speed we are not very sure whether they go at a constant acceleration. Shall I show you right now? Shall I show you the motion of something that would compared to all the examples you just gave? This example is almost perfect. Vivanti. When an object is thrown, how? Thrown how?
Miss drop.
Dropped. How do you know it's that the motion is along a straight line? I don't have to control. It will go in a straight line. Would I have to tell? Now go in a straight line. Do I have to tell it? No, it will go in a straight line. And the acceleration of this, because this air resistance, if you neglect the resistive forces, if you think they are negligible, this will be accelerating at a constant rate of what? How much? The gravitational, because it's falling under gravity. Gravitational, the natural acceleration that everything falls down under gravity. So that is a perfect straight line, right? Or even, if I throw this upwards, vertically upwards, that's a straight, it'll go right, like that, and come along the same line down. That's a straight line. Yeah, I have to throw it straight up. Depends on how I throw it. If you throw something vertically upwards, that's a perfect straight. It's moving in a straight line. So now the good thing is when we narrow down our motion into a straight line motion, there are only two directions you can move: forward or backward. That's it. There's no left, right, this way, that way. There's nothing like that. It's just forward, or if you turn and come back, backwards. That's all. Right? Only two directions. Right. So you wrote that. So let's write some examples of such objects that move in a straight line with a constant acceleration. Example. An object falling under gravity. an object falling under gravity. Come on. I'll give you a couple of examples. Come on. An object thrown vertically upwards. An object thrown vertically upwards. You have some here's another one. So see, this is like a nice object. If I release something on a slope, that goes in a straight line. I don't have to keep it. It will go in. If it can like slide nicely, that's better. Okay, or something that grows. Think of if you keep a ball on a slope, it will go in a straight line. Right? You don't have to steer it into a straight line. It will go in a straight line. That's just right. Yes. Conveyable means the rolling. Yeah. It's not accelerating, right? Yeah, the things that move along this
No, they go at constant speed.
yeah, they don't accelerate, but that's a straight line. Yeah, it's a straight line. The thing is, when you think of the straight line part, you lose the acceleration. That won't be there. When you think of constant acceleration, it's not moving in a straight line. So there are very only a limited number of examples you can think in nature who move like this. So we wrote two. Here's another one. Third, an object rolling down a slope. An object rolling down a slope. One more I can give. So this is difficult to find, but there can be things like this. A vehicle accelerating uniformly on a straight road. I can say that. If you keep the acceleration pedal like pressed to a constant, I mean, if you are driving on the highway, there can be sections where you are moving at a constant acceleration. So a vehicle accelerating uniformly on a straight road. On a straight road. Okay. And then a new line. Here are some things to remember, to keep in mind about this type of motion. You write, for this kind of motion, for this kind of motion, for this kind of motion.
Which paragraph?
Yeah, so a new line. For this kind of motion, then there are 3 bullet points coming. Here's the first bullet. Things to remember about this, okay? First bullet point. We have a starting point. We have the object has to start moving from a certain point. There is always a starting point to the motion. We have a starting point. That we call, or that we take, let's say that we take as the reference point in red. Reference point. You measure the distance traveled from that point. You measure the displacement from that point. That we take as the reference point. Reference point in red. That we take as the reference point from which to measure. From which to measure distance or displacement. Because remember, for both distance and displacement, you have to start measuring from some point. That would be the point, the starting point of the motion. We call it the reference point. So with relative to that, with respect to that, you measure the distance traveled. Second point. for this kind of motion, the second point, we only have two directions of motion in red, two directions. We only have two directions of motion. Come on, forward and backwards. Forward and backward. To indicate, let's say so. So, to indicate the two directions, so to indicate the two directions related with vector quantities, what are the vector quantities involved in a motion? Displacement, velocity, and acceleration. When you want to talk about those three related to your motion, to indicate the direction, you can just use positive and negative, because there are only two directions. Positive you can use for forward, negative you can use for backward. So you are not going to need northeast, north. You don't have to specify the direction with descriptions like that. 30 degrees from the north. You don't need that. If your motion is happening in a line, you are restricted to traveling in only two directions. And for those two, you can just use the two signs, positive and negative. So that's a huge simplification. When we study this motion, our math becomes very simple because of that. The two directions related with vector quantities. Vector quantities means if you want to say the displacement or the velocity, displacement, velocity, or acceleration. Now you know that when you give these, you have to specify the direction. You can do it just by using a plus sign or a minus sign. If you are moving like forward, what you call as forward, like for a motion under gravity, upward can be called positive, downward can be called negative. Right? So, so to indicate the two directions related with vector quantities, we can use plus and minus sign. Plus and minus sign. So convention is, again this is a convention. Convention is for forward motion, like forward means direction of initial motion. Is taken to be plus, positive. Opposite, its opposite direction.
So what's the word? Yeah.
Convention. So as a convention, now I mean you have the freedom to choose. I'm going to take this direction as plus, then the opposite to that direction is negative. But as a convention, so that we all stick to one way of taking things, the convention is to, if you are looking at an object moving in a straight line, the initial direction it moves, you take as positive. So then if it happens to come back later, that would be negative. Okay? So direction of initial motion is taken to be positive, its opposite direction is taken to be negative. Okay? That's a normal convention. And we wrote this before, but just to emphasize, when an object is decelerating, when an object is decelerating, it is considered as decelerating. It is considered as negative acceleration. Okay, so negative acceleration. Okay. Right. So this section is all about, now we are coming into the core of this section. So this section is all about how to find certain quantities related to a motion happening in a straight line with constant acceleration using math. So we have a bunch of formulas that we call equations of motion, and this again is some, have you done this in O levels? Equations of motion they are called. Why for physics in O levels?
No.
You didn't have equations of motion?
No. Not equals. It is some equation. Yeah.
What equations?
E equals to
You had only that in O levels. Okay, that comes from the definition of A formula. B equals C plus H. Okay. Okay. So now again, here's a summary. We are only looking at objects moving in a straight line with a constant acceleration. When you think of such a motion, you tell me what quantities can we talk about? Let me erase the board. When you think of an object that is moving in a straight line with a constant acceleration, what are the physical quantities related to that motion?
Speed.
What? Speed.
Time.
Wait. So, if you think of an object moving in a straight line, say from point A to point B, with a constant acceleration, usually acceleration is denoted with a double arrow. It's moving in this way, double arrow means accelerating. Acceleration symbol is A. Say it is uniformly accelerating from A to B. Now, if you consider this motion, what kind of questions or what kind of quantities can I talk about? For example, I can talk about how long did the car take to travel from A to B? The time. So time is one quantity related to this motion. I can talk about displacement.
Initial velocity.
I can talk about with what velocity did it start? With what velocity did it end when it was passing B? And what's the acceleration? There are 5, that's all. Can you think of anything else related to this motion? Any other quantity that you can talk about?
No, nothing.
There are only 5 things. The time it takes, the distance it travels, since it's a straight line anyway, it's displacement. Distance and displacement becomes the same thing here. Right? Do you realize that? Speed and velocity become the same thing here. So from now onwards, we'll stick to the words displacement and velocity. Anyway, it's the same as speed and distance since we are sticking into a straight line motion, right? So you can talk about the time taken, the displacement it happened from A to B, the velocity, the initial velocity, the final velocity, and accelerations. There are 5 quantities. And we have a set of equations that relate these quantities that we can use to solve problems related to this motion. For example, if I give you certain information, can I find the other information? If I give you the initial velocity and the acceleration and if you know 3 out of the 5 quantities, any 3, you can find the other 2 using these equations. I'll say that again. There are 5 quantities related to a motion in a straight line with a constant acceleration. Distance, displacement, time, initial velocity, final velocity, and acceleration. If I give you 3 of them, any 3 of them, you can find the other 2 using a set of equations called equations of motion. And we are going to learn them. There are 4 equations. Okay, we don't have time to write all of that. We'll just take a introduction. Okay, your subtopic equations of motion. Subtopic equations of motion. Equations of motion. Equations of motion. Right under that, one sentence. When we think of the motion of an object, when we think of the motion of an object, when we think of the motion of an object, when we think of an object, when we think of the motion of an object that is moving with a constant acceleration, from one point to another in a straight line, from one point to another in a straight line, from one point to another in a straight line. Come on. There are 5 quantities about the motion that we can talk about. There are 5 quantities that we can, there are 5 quantities about the motion that we can talk about. Then quickly sketch this. I have shown all the quantities using their standard symbols. I will give the list. Let's start with acceleration itself. So acceleration, I can ask, what is the acceleration of this object? Symbol is A. I can ask, what's the initial velocity? Means at the starting point, what's the velocity? Symbol is U. Final velocity. Symbol is V. What's the time taken? How long did it take to travel between these 2 points? Symbol is symbol T. And finally, the displacement. Symbol is S. S is the symbol for displacement. S. Let's make our car a little. It's actually, it's hovering above the road. It's like, it's floating. Okay? Okay, I'm going to stop from right this point. I will give you the set of equations next week so we can pick up from this point. So keep this in mind. We will learn the set of equations that are called equations of motion and learn how to use them to solve problems. That's all you have in this, and then you have graphs also, motion graphs, displacement time graphs, velocity time graphs. Little bit of that you have done in the O-levels, I know. Okay, right. So let me